Oh. Deepti, have you stopped presenting?
Yes, sir, I stopped sharing the screen. So will I share the screen?
Mm, no, because I can't present now.
So will I share the screen?
No, no, I have to. I want to show something. Uh,
Oh,
okay, I'll try later. Um, who was the second person? Ahana Bishash. Is she there? No, Ahana has left us. Okay, so the third person is Audit Shaha. Audit, can can you start presenting, please? Yeah, it's visible. When you're ready, please start presenting. But you're not audible. You have unmuted yourself. I can see, but you're not audible. Can anyone hear Audit?
No,
no,
sir. No,
no,
sir.
sir.
No, sir.
No, sir. No, sir.
Audit, you have to shout. You have to shout so loud that everyone can hear you. Okay, Audit, can you at least? Oh, I think there's some problem over here. You can't unmute. Uh, yeah, Audit, I think it's best if you can log out and then log in again. Audit has seems to have left us permanently. In that case, Upanita Bormon, I think you were the last person remaining. Can you start presenting, please? Upanita?
Yes, sir.
Yeah,
Yes, sir. Just a second, sir.
sure. When you're ready, start presenting. I'm muting myself.
Yes.
Sir, am I audible?
So, is it visible?
Yeah. Audit, let Upanita finish. After that, you can start presenting. Okay.
Sir, am I audible? Just cool.
Yeah, you're audible. You're
Okay, sir.
audible.
Thank
But
you, sir.
don't present now.
Okay,
Okay.
okay, okay. Thank you.
Yeah, Upanita, please.
Good evening, everyone. My name is Upanita Burman, and my PPT is on logarithmic function. We begin with the definition of logarithm. The logarithm of the number x to the base a is the exponent indicating the power to which a must be raised to obtain the number x. It is designated as log x to the base a. I would like to demonstrate it with the help of an example. If we have 2 to the power 3 equal to 8, then we demonstrate this as log of 8 to the base 2 equal to 3. Next, we proceed with the domain of the log function. We have assigned log x to the base a to a variable y, which implies that x equal to a to the power y. This is only possible if a will be greater than 0. If I would like to demonstrate it with the help of an example. If a is equal to minus 2, then y will be minus 2 to the power x. If x assumes a to the power x, if x assumes if y assumes a value like half or something, then minus 2 to the power half will not be a positive number. It will be an imaginary number. A will not be equal to 1. If log 2 to the base 1 is equal to y, I don't think that is possible. Then we won't get a possible number. And x has to be greater than 0. If we take all valid values of a and we assign a equal to 2, then x equal to 2 to the power y, which is always positive. Therefore, x will be positive. The domain of the log function is from 0 to infinity, and range is a set of real numbers. If a is greater than 1, the function is increasing and concave. And if a is less than 1, the function is decreasing and convex. I will explain this with the help of a graph in the later slides. And this is how we denote a log function. If the base is equal to 10, which is if a is equal to 10, we call it a common logarithm. It's like here, like this. And if the natural logarithm, if a is equal to e, we call it a natural logarithm, which is also represented as ln x or log x to the base e. I would like to present the two types of graphs which are possible. In the previous slide, we had discussed two cases when a is greater than 1 or less than 1. Suppose we assume a value a greater than 1 and we assign y equal to log x to the base 2, and we take several values of x and find out y accordingly. This is the graph which we get when we plot these values. As a result of which the graph plotted is increasing and concave that we just got to show in the previous slide. Here is a function where we have taken a less than 1. If y is equal to log x to the base half and we take several values of x and plot and calculate y accordingly, we get the graph as this. And as in the first slide, we also see the graph is decreasing and convex. This is how it looks when the two graphs intersect. The point of intersection means that it is a solution for both the equations. And if we have log x to the base 1 by a, which is equal to log x to the base a to the power minus 1, which is further equal to minus log x to the base a. The laws of logarithm are as follows. If we have log m to the base b plus log n to the base b, where both the bases are common, then our possible calculation is the logs, the m and n get multiplied within the log function when the base is the same, that is b. Similarly, when log m to the base b minus log n to the base b, we get them as m by n, where the as a log function where the b is the base, is the common base. Log n to the power k to the base b is equal to, the k comes outside, k into log m to the base b. We all know this as log 1 to the base b is equal to 0, because b to the power 0 is always equal to 1. Log b to the base b is equal to 1, because we know that any number to the power 1 is the number itself. Log b to the power k to the base b is equal to k. I think it is pretty similar, like b to the power k will be equal to b to the power k over here. And any number to the power log, like b to the power log k to the base b, will give us k back. This is all possible if b is greater than 1 and not equal to 1, and m, n, and k are real numbers, and m and n have to be positive. Thank you, everyone.
Thank you, Upanita. Very smart presentation. Does anyone have any questions? Okay. Audit, you can
Yes, sir.
have your turn now.
Yes, sir.
Yeah. Please present.
So, good evening, everyone. This is Orish Shah. So, as in the last class, I discussed about the function. There are different kinds of functions, and linear function and non-linear functions are one of that. In case of linear function, we have seen that if the function creates a straight line, it called linear function. And in case of non-linear function, when the function does not create a straight line but creates a curve, it called non-linear function. And the slope is also varies between point in case of non-linear function. There are different kinds of non-linear functions too, like quadratic function, logarithmic function, rectangular hyperbola, and power and exponential. So for today, my task was given to prepare a slide on power and exponential function. So coming to the power function, I think we all know what power and exponent in mathematics is. When a number a is multiplied by itself n times, we write a to the power n, where n is the exponent or power. Algebraic representation of power function is f of x or y is equal to x to the power b, where x could be the any real number. Here you can see some types of graph of power function. In first case, when positive, the constant is positive when a is greater than 0 and b is greater than 1, positive event power, it will create a graph like this in upward direction. If we take negative value of x, it will give positive value of y, and if we take positive value of x, it will give positive value of y. So it will create a graph on first and second quadrant. In case of negative constant, when a is less than 0, it will create a graph in third and fourth quadrant, because if we take negative value of x, it will give positive value of y, and if we take positive value of x, it will give negative value of y. Coming to the second condition, when positive the power is positive odd, when b is greater than 1 and positive constant a is greater than 0. In this case, when we take negative value of x, it will give negative value of y, and if we take positive value of x, it will give positive value of y. So the graph will be on first and third quadrant. In case of negative constant, in if we take negative value of x, it will give positive value of y, and if we take positive value of x, it will give negative value of y. It will create a graph in second and fourth quadrant. In these four cases, we have seen that the graphs are passing through the origin, because if we take, in case of b is greater than 1 and even power, even or odd both, if we take x is equal to 0, it will give y is equal to 0. So it will pass through the origin. But in this case, when the power is negative or minus, less than minus 1, uh, and positive constant, it will not pass through the origin, because if we take x is equal to 0, it will not give any value y but give us infinity. So in this case, when we take negative value of x, it will give positive value of y, and if we take positive value of x, it will also give positive value of y. So it will make a graph on first and second quadrant. In case of negative constant, when a is less than 0, and negative even power, when b is minus, less than minus 1, it will create a graph on third and fourth quadrant, because if we take negative value of x, it will give negative value of y, and if we take positive value of x, it will also give negative value of y. So it will make a graph on third and fourth quadrant. In case of negative odd power, when b is less than minus 1 and positive constant a is greater than 0, if we take negative value of x, it will give positive value of y. Sorry, negative value of y, and if we take positive value of x, it will give positive value of y. So the graph will be on first and fourth quadrant. Similarly, in case of negative constant, when a is less than 0 and b is less than minus 1, if we take negative value of x, it will give positive value of y, and if we take positive value of x, it will give negative value of y. So it will create a graph on second and fourth quadrant. In this case, you can see that we are not going to take a is equal to 0, because if we take a is equal to 0, in this case, whatever the input of x is, it will give y is equal to 0, always give y is equal to 0. So it will not create any graph but create x axis. So we are not going to take a is equal to 0. Here you can see some of special cases when b is equal to 1 or minus 1 or b is equal to 0. In first case, when we take b is equal to 1, y will be is equal to ax, but and y by x is equal to a. It will give a constant slope of a straight line. It will create a linear function with constant slope. So in when b is equal to minus 1, y will be the a to by x, and x could be any real number but not 0, because if we take x is equal to 0, it will not give any value y but give us infinity, and it will have a constant area xy is equal to a. It will create rectangular hyperbola. In this case, it will very similar graph of, in this case, it's like look like very similar but not exactly. When b is equal to 0, we take b is equal to 0, it will what the value of input of x is, but it will give x to the power 0 means it will always give 1. So y will be the 1, sorry, y will be a. In this case, it will create a straight line parallel to the x axis, because if we in any value of x, it will give y is equal to a. Coming to the exponential function, first of all, I want to say it's very easy to confuse between power and exponential function. In this case, in power function, we have seen that we have two parameters, and the base x is variable, but the exponent or power is fixed. But in exponential function, here you can see that the base is always fixed, but the power or exponent variable. If we take the exponent as variable in this function, we then obtain the exponential function. Algebraic representation is obviously y is equal to ab to the power x. Here you can see when a is greater than 0, the graph represents look like this. It will not pass through the origin, because in case of exponential function, when a is greater than 0, the graph represents look like this. It will not pass through the origin, because it will always give y is equal to a, and in case of a negative, when a is less than 0, in third and fourth quadrant. In this case, if we take a is equal to 0 or b is equal to 0, y will be strictly 0, and it will not create any curve but create the x-axis. And in case of b is equal to 1, whatever the value of x is, it will give y is equal to a, so it will create a straight line parallel to the x-axis. In many applications, we have seen that the base b is given as is e, which value is 2.718. We call this Euler's number. In very of this, in calculus, we have seen that the base is as e. In exponential function, we have a restriction. The base must be positive, because if we take negative value of b, and in case of rational power like half or 7/4, it will not make any algebraic sense but create a complex number. So we have to avoid b, negative value of b. So this is the only one restriction in exponential function. So that's all from my side. Thank you.
Thank you very much, Arit. It's obvious that all three of you spend a lot of time in making your presentations. Arit, where have you come from?
I'm from Phalagata, sir.
Where is it?
In Alipurduar.
Alipurduar.
Yes, sir.
আচ্ছা, আচ্ছা। আচ্ছা। I'll quickly take the roll call and then I'll continue the class. So those with roll numbers between 4 to 20, please unmute yourself. Poonam Chaudhary, absent. Deepika Paul,
Yes, sir,
present.
present.
Ahon. Deepika, right?
Sir, Poonam
Or
Chaudhary.
Poonam. Oh, Poonam. Okay. Ahona Bishas, absent. Sneha Sutrodhar.
Present, sir.
আচ্ছা, দেবপর্ণা মজুমদার, absent. Sheikh Shahnil Hussain, absent. Shantika Paul. Orit Shaha, present.
Yes, sir.
Akanksha Shaha.
Present, sir.
Okay. Upanita Barman is present. আচ্ছা, 21 to 40. Please unmute yourself. Upanita Barman. Oh God. Eshita Sarkar, 23. Rick Ghosh, 24. Sajid Khan, 26.
Present, sir.
27. Oindrila Mukherjee.
Present, sir.
32. Kritika Ghosh.
Present, sir.
33. Anandarupa Dhar.
Present, sir.
35. Prithviraj Bishas.
Present, sir.
36. Anushka Pal.
Present, sir.
Monideepa Dhar. Ayan Ukil. Shantanu Borai.
Present, sir.
Okay. 43 to 60. Aryan Singh.
Present.
Ria Ratan.
Present, sir.
Arpan.
Yes, sir.
Rajdeep.
Present, sir.
Rajeshri Khan.
Present, sir.
Rohan Koyal. Vaibhav Agarwal.
Present, sir.
Srija.
Present, sir.
Orgho. Sanveer Alam Gain.
Present, sir.
Oishani Ghosh.
Present, sir.
Shaumopriti Pal Chaudhary.
Present, sir.
Rajeshri Datta.
Present, sir.